Hello, everyone at the session Best Practice for Implementing Storage Spaces Direct 2019. My name is Carsten. I'm from Germany, maybe you hear that, and I'm a cloud and data center management MVP now in my 8th year. And I do with my company a lot of storage spaces direct implementations. In fact, we have done over 100 production implementations over the last 2 years with customers. Now you maybe think, today Windows Server 2019 was announced. How can he talk about best practices with 2019? So that's very easy. First, there is the Windows Insider Server program. Who of you is in the Windows Insider Server program? A few of you? That's a great program. You get the builds, the pre-builds for the version already, and you can try them out. Of course, it's not production software, so it is to play with. There are some flaws in it, but you can get, how you say it, you can see how it will work with 2019. And then, what is true with Windows Server 2016, what is best practice with Windows Server 2016, is still true with Windows Server 2019. So most of the best practices, of course, are from our projects with Windows Server 2016, and you can apply the same best practices to Windows Server 2019. So I have only 20 minutes to talk about some best practices. That are not all of them. There is more. You can come to me to the Microsoft booth tomorrow if you're interested in the stuff. There are a lot of Microsoft experts for storage spaces direct. Talk to them, talk to me. And I will tell you 7 tips that we see mostly be done wrong in customer implementations. So the first one is RDMA. RDMA, you know, I'm not Microsoft, so I can say do storage spaces direct always with RDMA. There's a huge need for low latency traffic between the hosts, the east-west traffic, and for me, it doesn't really matter if you go with IWAP or with Rocky. We have done a lot of Rocky implementations in the past, and there are some problems with that. We talk about that a little bit later. And today, every OEM has also an IWAP card in their offering. So if you're curious about the network stuff, go with IWAP. It's also a Microsoft recommendation now because it's much easier to implement than Rocky. So, but if you know what you're doing, you can do Rocky quite well, and there are a lot of good implementations with that. If you do Rocky, you have to configure Rocky RDMA correctly on the host. Because Rocky, there is a demand that the switches can identify the Rocky packages. Rocky, in essence, is InfiniBand over Ethernet. And the protocol, if it loses packets, you have problems. So you have to tell your switch, this is a Rocky packet, and it's very important, don't lose it. And to do that, you have to tag your switches on the host. There are PFC classes for that priority flow control. And you also have to tell your switch, this PFC class, for example 5, don't lose that packages. They have to handle those packages lossless. They can throw away every other package, but not the Rocky package. And there are also pause frames involved. And another best practice in our scenarios, don't route Rocky traffic. If you do Rocky v2, it's routable, it's IP traffic, you have UDP packets, it's encapsulated in IP and in UDP. You can route it, but don't do that. Stay in a subnet. Stay in a layer 2. If you look at IWAP, there is not so much that you have to be careful with. IWAP, in essence, you have 2 network cards that are doing RDMA to the host, and on the network they do TCP/IP. TCP/IP we know for ages, so I think if you ask you what is a gateway or what is a subnet, you know that. And TCP/IP is easy. So you don't have to do anything on your Ethernet switches to transport TCP/IP, because the protocol cares about itself. If a packet is lost, it will be retransmitted. Okay? So, but still, don't route it. If you route the traffic, you have more latency, and why do that in a small deployment where we have only some racks to span? And if you do high performance IWARP, so let's say 40, 50, 100 gigabit IWARP, also consider doing PFC in the switches. If a packet is being lost, that's not a problem. It will be retransmitted, but the performance is going down because you'll lose packets. So with high performance IWARP, also consider using PFC. Next one, network best practices. So this is me drawing on my tablets to show you what I mean. So this is S2D node, a hyper-converged S2D implementation. So we have Hyper-V and the storage in the same nodes. And we have some network demands. We need network for our VMs. So we have an Hyper-V switch. And there are two possibilities now with Windows Server 2016 or Windows Server 2019. You can go with an LBFO team and a switch, and you can use the switch embedded teaming, the new switch, a new star or, on the block. So if you do that with the SET switch, you can use those network cards for all the traffic needs you have. So management, you can use them for SMB, you create some virtual SMB NICs here, but in our experience, it's much better if you have separate NICs for your SMB traffic. Do the SET switch, because all the good stuff from Windows Server 2019 is implemented in the SET switch. For example, we have VRSS, we have vRDMA, even in the VMs, we get RDMA capability. We have DVMMQ, that's a new virtual machine queuing, that's really great, and you have RSC, all in the SET switch, not with the LBFO team and the standard switch. You need the SET switch for that. And there is a booth over there on the Microsoft booth. It's from the networking guys, and if you are interested in networking, talk to them. They have all the good stuff that they can show you. So I like to separate the SMB adapters. I like to have two separate SMB networks. So the reason for that is, if we have an SMB1 in a separate IP network, all the traffic between all the network cards in the different hosts are in the same switch. There's no demand to cross a switch border, because the connections between the switches are sometimes not big enough, and there's a reason for congestion. So there is the queues are filling up, and then the switch has to throw away packets. If you stay with your SMB traffic from one subnet in this switch, there is no congestion because we are staying in the same switch. Yeah? If you go with storage spaces direct, and this may sound crazy, if you have two 10 gigabits networks for your SMB traffic, that's a minimum requirement from Microsoft, and I would say go with faster network. So today, 25 gigabit NICs are available from every vendor. They are not much more expensive than the 10 gigabits. And if you do NVMEs here as storage devices, 2 times 10 gigabit don't give you all the bandwidth that an NVMe needs. So you are paying for NVMe, but you don't get the full NVMe performance because you have not the bandwidth between the hosts. So consider doing more network here. And there we are going to devices. So we see a lot of problems with devices and not rightly sized devices. The most problems are with flash devices. And in a storage spaces direct deployment, you have to have flash devices. There is no deployment with only HDDs. It's not supported. You need flash devices. You have either an all-flash deployment or an HDD deployment with caching devices with flash. So Oh, I'm on the wrong slide. Sorry, I'm talking about resiliency. Was he talking about? I'm talking about resiliency. Sorry for that. There are different kinds of resiliency you can use in your deployments. The fastest one, with no doubt, is the three-way mirror. So you have 3 copies of the same block on 3 different servers. That give you great resiliency. 2 servers can fail if you have a 4-node design or more. Yeah, so you can lose 2 of those servers, and you have great performance. If you don't want to spend all the money here, because if you want to have 50 terabyte of usable space, you need, with a 3-way mirror, 150 terabyte of devices. And if you go all flash, that is a little bit expensive. So there are other options. You can go with the mirror accelerated parity. And I actually love this design. So we have, in the mirror accelerated parity, we have a part of a volume or virtual disk is a 3-way mirror, and the other part is a double parity. So you get the best of both worlds. You have a fast write in the 3-way mirror, because ReFS always writes in the performance tier, that's the 3-way mirror. And then if the 3-way mirror fills up, there is like an online tiering moving the coldest data between the 3-way mirror to the double parity. And that's great. You get a better usage of your devices than 33%. We are talking between 33 and 50% with 4 nodes, depending on how large your 3-way mirror is and how large your double parity. And if you go more nodes, you even get a better usage of your devices. But take the 3-way mirror for the writes. That's very important. And with 2019, it's even great with deduplication, because the deduplication process takes place when the data is moved from the hot tier to the cold tier. Then the deduplication can take place. So then there's another option, double parity. It is supported, but not recommended. If you want to go double parity, add at least a little bit mirror in front of it, and you get much better performance. And there is the 4th option, a 2-way mirror. I would only do a 2-way mirror in a 2-node storage spaces direct design. If you have 3 nodes and you lose 1 disk in 1 node and a disk in another node, your data is not accessible anymore. So 2 disks with 3 nodes or 4 nodes or 5 nodes in 2 different nodes, your data is gone. So you can use your backup. 2-way mirror is not an option in our design unless you have a 2-node cluster. Then you can only do a 2-node mirror. Yeah? So here's the storage devices. I told you already you have to have flash devices in there. And if you use flash devices for caching, use the write endurance. I've seen implementations with NVMEs where the NVMe has only a DVPD of 0.8. And in this caching device, there are also the metadata of all your data where it is placed in your storage spaces direct. So if the flash devices are not working anymore, you have maybe a problem with losing metadata, and then all your data is there, but the storage system doesn't know where it is, because this data is stored in the fastest devices. So your fastest devices should have the best endurance in your cluster. So when you use flash devices for caching, go with a DVPD of 3. DVPD stands for disk writes per day. It's a measurement how often you can overwrite a disk per day, and it will be guaranteed that it holds 5 years. After that, it can fail. So it's a measurement how often you can overwrite a flash device. For capacity devices, 1 to 3, depending on how much write workload you have. Caching devices, you should have 2 at least. I've seen cluster implementations with 1. That works great if your disk doesn't fail. So if you have HDDs and 1 flashing device, that works. But if your disk fails, you're going down to the pure HDD performance, and that is killing the performance in the whole cluster. Not only the 1 node, in the whole cluster. So always use 2 of them. And if you choose those devices, look at the 4K random write performance. There are NVMEs out there with 27,000 IOPS. That sounds amazing, but there are others with 500,000 IOPS. There's quite a difference between 20,000 IOPS per second and 500,000 per second. And that makes a difference in your performance. And choose NVMEs over SSDs whenever possible. The price difference on the market is nearly 30%, 30 to 40% for the same flash device. One having an NVMe interface, the same one having a SATA or SAS interface. It's only 30% more. I know that's a lot of money if we're talking about terabytes of flash devices. The performance is at least 3 times faster with write. Read maybe 9 times faster, so you get a lot of more for your money. Oh, I have to hurry. Sizing best practices. So if you look at a storage spaces direct design, you think, oh, I want to have 50 terabyte usable space. And then you have to design your storage around it. Your OEM can help you with that. There is a calculator from Cosmos Darwin in the internet. You can use that. That's a good start. And there is a feature called parallel rebuild. So imagine an HDD failing, a 4 terabyte HDD. If you can rebuild, if you would have a hot spare, if you can rebuild the data, the 4 terabyte, on this disk, and you write it with 100 megabyte per second, that's fast for an HDD, it takes you 11.5 hours to restore the 4 terabyte of data. So Microsoft says, no, hot spare is not supported in Storage Spaces Direct. Leave unused space in your storage. And then if a disk fails, there is a parallel rebuild in the free space on multiple HDDs. And each of them can have 100 megabyte of performance. So if you have 4 instead of 1, you are rebuilded 4 times faster than with 1. So use that, use parallel rebuild. If you don't have that, you have a disk failure, you have to wait for the new disk. That maybe takes a day, depending on your service level. And then you have to take the old one out, the new one in, and then the rebuild starts 11.5 hours. So you are 2 days with a lower resiliency in your storage. And much better is you have free space. The system recognizes, oh, there is a failure of a disk. Let's immediately start to rebuild. If you have different storage tiers, like the 3-tier design, you have caching devices, you have performance devices, you have your capacity devices. So we, in our designs, we use 10% for caching, at least. I know that sounds very expensive, and it is sometimes, but you have a very performant design. Don't go with 2% or with 3%. With 10%, it works really, really well. And if you have a 2-tier design for your capacity devices, so for your data, SSDs, HDDs, spend 20% for your SSD tier and you are golden. It's rock solid, rock performant. It costs money, I know, but you want to have a nice hyperconverged design or a nice storage design. So I have 3 minutes left. 2 more tips. If you're thinking about buying a Storage Spaces Direct solution, there is a Microsoft program for that. It's called WSSD. It stands for Windows Server Software Defined. It's a Microsoft certification program for the OEMs where they download a test suite, test their stuff a week, 5 days, and it will emulate the life of a Storage Spaces Direct implementation of 1 year. Failing devices, looking how it works, and so on. And this is an old slide. Today there are 13 vendors. We have 52 solutions where you can pick from your favorite vendor. and see what they have tested with Storage Spaces Direct end to end. So it's a nice program, and if you are more interested about that, you can go to the Microsoft booth, talk with the guys, or I have tomorrow a theater session about the VSSD program, I think in this theater, again at 5:40, if you are interested about that. And then my last tip, if you want to have a nice management experience with Storage Spaces Direct, Windows Server 2019, but also with Windows Server 2016, because Microsoft backported the Windows Admin Center for Storage Spaces Direct 2016. You have to have the May update installed, and you have to register 1 cluster resources. Then you can manage with Windows Admin Center also your actual designs. And that is very nice. You have a HTML5 based user interface. You have a lot of performance data there. That's in Windows Server 2019. You can even see the performance of a single disk. And Microsoft stores the data historically, so you can see how was my disk performing when I bought it, how was the average latency, and how is it now, 2 years afterwards. And so you can detect devices that are not as performant as the other devices from the same vendor. And that's very helpful. And there are even now event logs for that in the Windows Server with Storage Spaces Direct. So if you didn't have it already, look at the Windows Admin Center. It's a very nice experience, especially for the hyper-converged Storage Spaces Direct design. So it would be really nice if you evaluate this session so that I know if I was good presenting the stuff or not so good. So please go to your mobile app or the website and evaluate my session. And thank you very much for your attendance. I'm right on time. Have a nice evening, and I hope I see you tomorrow. Thank you.